Potential of the conductor.
A potential. Then so the distance between the plates, if increased, this is going to be decreased. Then if it is going to be increased. Okay, so then anything. So we are taking this in some medium, right? So what is the medium in between the plates is also a depending factor. Okay,
area of plates.
Yes, area of plates. Very
Area
good.
between the plate.
Yes, area of plates. Yarido.
Ma'am, Kushit.
Good question. Area of the plates. Next one.
Ma'am, unsend that message, ma'am. My father is scolding, ma'am.
ఎన్నిసార్లు పిలిచేదిరా నిన్ను?
మ్యామ్ నెట్ సరిగ్గా లేదు మ్యామ్.
ఓయో మీ ఇంట్లో నెట్ లేదంటే ఇంకేం రా కుషేత్. నీకిచ్చినంత ఇది ఏమంటారు కంఫర్ట్ జోన్ ఎవరు ఇచ్చుండరు నేను ఇప్పుడు మీ బ్యాచ్ లో అయితే. నువ్వు కూడా అలా
కంఫర్ట్ జోన్ మ్యామ్.
చెప్తా. ఓకే, సో ద నెక్స్ట్ ఫ్యాక్టర్. And nature of medium, let me say. Okay, nature of the medium. Okay, so this thing is about your capacitor as well as what is the capacitance of a capacitor. Okay, please take it on fast. Take it down.
One minute.
Yeah. Then so then what do you mean by capacitance of a capacitor? It is a ratio of the what is Q?
Charge.
What is Q? Charge.
And potential.
And what is V?
Potential.
Yes, it is the ratio of the charge to the potential. Then students, can I go for next page?
Yes, ma'am.
We'll finish the theory part on this because so many numericals will be arised in this part. So that is very important. Okay, done?
All right, please.
Jitin?
Yes, ma'am.
Yes. Jitin, yes.
Yes, ma'am.
On your video.
What is that last two, ma'am?
Area of the plates and nature of the medium. Nature of the medium in between the plates.
Done, ma'am.
Yes. Okay. So the capacitance of a capacitor is a C is equals to Q by V. Okay. So let me write for the SI unit of a capacitance, SI unit. Okay. How you're going to measure the charge?
Microfarad.
Charge.
Coulomb.
Charge. How
Ampere.
you're going to measure the charge, I'm asking. Ampere. Very good.
Coulomb.
Current ing measure ಮಾಡ್ತೀರಾ?
Current is ampere, ma'am.
Current ampere, ma'am. Ampere.
Coulomb.
Current ampere. How you're going to measure the charge?
Coulomb.
Coulomb. How you're going to measure the potential?
Volt.
Volt. Okay. So let me define the SI unit of a capacitor. So the SI unit of a capacitance is the 1 stat coulomb per 1 stat volt. Okay, 1 stat coulomb per 1 stat volt means, so it is said to be a 1 stat farad. Okay, 1 stat farad is equals to 1 stat coulomb divided by 1 stat volt. Okay, so here if you want to define the farad means, you one temperature, sorry, you will raise the potential of 1 volt to the for the one unit charge. Okay, so the capacitance of a capacitor is said to be 1 stat farad means the potential rise through a 1 volt when a charge of 1 stat coulomb is given to it. Okay, so if they ask like, what you mean by stat farad means, you can define like this. By looking at this only you can define. So you are going to raise the 1 voltage, 1 volt of the, what you say, 1 voltage potential rise of the 1 stat volt when a charge of the 1 stat coulomb, 1 stat coulomb is given to it. Okay, so that a unit of the capacitance. What is the SI unit of the capacitance? A farad. So this may be in terms of microfarad or nanofarad will be there. A micro means 10 to the power of minus 6 nano, 10 to the power of minus 9, a millifarad 10 to the power of minus 3. Please remember this. Okay, so the micro is the 10 to the power of minus 6 and the nano is the 10 to the power of minus 9 and the milli is the 10 to the power of minus 3. Okay, is it clear, students? So what is the SI unit of a capacitor? What is the SI unit of, yes, farad. Okay, how you are going to define the farad? Kushit? Kushit ready?
Yes, ma'am.
Please respond.
Yes, ma'am.
Please tell me the definition regarding the farad. ఇప్పుడు నీ నేమ్ తీసేస్తాను రా డెఫినేషన్.
Ma'am, I don't know, ma'am.
చూసుకొని చెప్పురా, ఇప్పుడు ఏం వింటున్నావు?
Physics class.
మరి ఇక్కడ రాసాను కదా.
One, అదేం మీరు రాసిన సరిగా అర్థం కదా నాకే.
స్టార్ట్.
1 stat coulomb by 1 stat volt.
I know formula. Just define.
Ma'am, 1 minute, ma'am. Let me think. I'm not getting.
Next, Abhi.
Ma'am, the ratio of 1 stat coulomb by the 1 stat volt.
Okay. So they are exactly defined means, so you need the 1 stat farad means to rise the 1 potential stat volt to the for the 1 stat coulomb of the charge. Please write like that. Okay. Okay. Okay, students.
Ma'am, if they ask the definition, we can't write this formula, ma'am. They won't give us marks.
No. Definitions, define and all. You need to write very correct answers, accurate one. So let me write here the capacitance of a capacitor. So if you want, I'll write here the capacitance of a capacitor is said to be 1 stat coulomb. 1 stat coulomb. Sorry, 1 stat. What do you say? Farad. 1 stat farad. If it's a potential rises, if it's a potential rises through 1 stat volt, 1 stat volt when a charge off and 1 stat coulomb is given to it. Try to write. Now can you define question?
Yes, ma'am.
Yes, tell me.
Capacitance of a capacitor is said to be 1 stat farad if its potential rises 1 stat volt when charge off and 1 stat coulomb given to it.
Yes. Now tell me. Once again, question.
Capacitance of a capacitor
Yes.
is said to be
Yes.
1 stat farad if its potential rises through and 1 stat volt when charge off and 1 stat coulomb given to it.
That's very good.
Ma'am, please.
Okay, then.
Yes, ma'am. Thank you, ma'am.
Question is responding now.
Yes, ma'am.
Okay, fine. We can open a space.
1 minute.
Yeah. Then the next one is your dimensional formula for the capacitance of a capacitor. So what is the dimensional formula for DC? Sorry, Q. So ampere into time. So here voltage is M power 1, L power 2, T power minus 3, minus 3, ampere power minus 1. So let me write. So the dimension for a capacitance is M power minus 1, L power minus 2, T power, here T power 4 and A power 2. in 1 mark question also they may ask, in the KCT also they may ask the what is the dimensional formula for the capacitance of a capacitor. Okay, done. Can I go for next page?
1 minute, ma'am.
Yeah. Next chapters will be in next chapters you will learn about resistors, you will learn about cells and all. In this chapter, capacitors.
You can continue.
Yes. So let me take next page. So the capacitance is done. What do you mean by capacitance? What is the use of capacitance? What is the capacitance of a capacitance? And what are the dependence factors? What is the SI unit of the capacitance? So how you are going to define the farad and what is the dimensional formula? This is some basic things about your capacitance and the capacitor. Okay, so we'll see the what is the working principle. Okay, so let me explain a capacitor. So the capacitor and its principle. Okay, usually it consists of the two plates here. Okay, so the one thing is with your, if you assume that it is the A plate and this is the B plate, it is a full of positive charges here, it is a full of negative charges here. Okay, so if you see here the capacitor means it is essentially consisting of the conductors are separated by the some medium here. Okay, this is, I can say it as the insulating medium. What do you mean by insulating medium? In between this place there is no conduction is happening. Okay, so I will take the two conductors which is separated by some insulating medium called the, I can say it as the insulating medium or a dielectric. Okay, dielectric space, I can say it as the a dielectric space in between these two places. So the whereas the other is one is earthed thing is it is going to be earthed one. Okay, so then I can say it as this is the capacitor. Okay, so the capacitor means it is a I can say that it is an arrangement of the storing a charges. Means charges means a large amount of the charges also you can store it. Okay, storing of the large amount of the electric charges, a large amount of electric charge in small space. Okay, so this is the, so this is about your capacitor. And so what is the working principle? Let me explain you a working principle. So here I will take the two conducting plates here, and then which is the insulated and charged conductor is another one is earth one. Okay, so when you are going to earth here, what will happen? Okay, so here these two are metallic plates and these are the positive charges here and negative charges will be there. So when it is earth, what will happen in the B plate? Yes, what will be happen in the B plate?
It will flow towards the ground.
Yes, it is flow towards the ground. Which type flow? Yes, which type of the charges will flow? The negative charges, right? So then I can say that the slightly there is a reduction of the charges in the plate B. right? So then whenever the slightly reduction in the charges in the plate B, then these charges will be occupied on the other two plates also. So due to that, we can say that the large amount of the charges, okay, I can introduce here. Okay, so this is the thing. So this one will be clear with your thing like a spherical capacitor working. If you see over there, you can easily understand. So let me take this. So let me write a parallel plate capacitor. We'll go with one by one. So capacitance of a parallel plate capacitor. Capacitance of a parallel. Same thing what I have taken in the last thing. I'll take that diagram itself. Let me draw one plate, and this is the another plate. Okay, students? Yes or no? So let me draw here some charges here. So here it is a positive. Okay, here it is the negative. Is this capacitor? Now I will this to ground. Okay, so this is the plate A and this is the plate B. Okay, so these two are separated by the some distance D, or I can say that this is the dielectric space. Dielectric space. Okay, is it clear? So we are going to see the what is the capacitance of a parallel plate capacitor first. Okay, so let me consider one parallel plate capacitor which is consisting of a plate A and a plate B. Plate A is a full of the positive charges and the plate B is a full of the negative charges, and another plate is a grounded. Okay, as it as it clear from your things, right? So what will be the charges here? Let me write it as a plus q, and what will be the charges will be here minus q. Yes or no? So can you tell me from this what is the surface charge density on this plate? Yes,
Sigma,
what is the surface?
sigma is
Yes,
equal to Q by A.
q by a, right? Surface charge density. What is the surface charge density formula? Sigma is equals to total charge divided by area. Surface area charge density. Charge here is a Q and by A. Okay. So let me write. So the sigma is equals to Q by A. Right. So here it is also charge, magnitude of charge by A. Okay. So in the both ends, I can say that. So sigma is equals to here is a Q by A. Here it is also a Q by A. So then what will be the charge on the both side? Q is equals to sigma into A. Is it clear, students? Yes or no? This is the surface charge density. And now tell me what is the electric field on this plate? Electric,
E is equal to sigma by 2 epsilon naught.
yes. So electric field due to a plate 1. Let me write a plate. So let me write it as E1. E1 is equals to sigma by 2 epsilon naught. Then E1 is equals to, can I write it as a Q divided by 2a epsilon naught? Yes or no? Yes or no?
Yes, ma'am.
Yes. Now, can you tell me what is the electric field due to a second plate?
Sigma by 2 naught.
I this is the magnitude of charge, ma. Sigma by 2 epsilon naught. Then E2 is also a Q by 2a epsilon naught. Okay, is it clear? So let me take what is the total electric field. Total electric field. So let me write it as E is equals to a sigma by 2 epsilon naught plus 2 sigma by 2. Then E is equals to 2 sigma
2
by,
epsilon naught.
then what is the
Sigma
total
by
value?
epsilon naught.
Yes, sigma by epsilon naught. This is the E net, right? So now just tell me what is the relation between the electric potential and electric field? Yes, a relation
Ma'am, minus
between.
dV by dr.
D by df.
Okay, yes. Relation, tell me in a magnitude value, ma. A relation between E and V. Can we write it as a E is equals to dV by dr or V by
Yes,
R?
ma'am.
Here, R is equals to the space in between them, the distance. Can I write it as a D here? Yes, or V by D. So this is the electric field and this is the another electric field. So let me write it as equation 1 and 2. Now can you equate equation 1 and 2? Equate equation 1 and 2. Then what will happen? Sigma by epsilon naught is equals to V by D, right? So now tell me V is equals to how much, ma? V is equals to sigma D by
D by
epsilon.
epsilon naught.
Very, very good. So now just tell me what is the capacitance of a capacitor? What is the capacitance of a capacitor? Capacitance of a capacitor. Yes. What is the capacitance of a capacitor? Q is equals to a Q by, yes, Q by V. ಏನ್ ಮರ್ತೋಗ್ತೀರಾ ಹಾ ಇಲ್ಲೇ ಮಾಡಿದಿರಲ್ವಾ C is equals to Q by V. Just apply here Q by V. Q divided by V is a sigma D
Sigma
by
D by epsilon
epsilon
naught.
naught. What is the this one sigma? What is the sigma value?
QA. QA.
Q Q by A, ma. Q epsilon naught a Q by A D. Epsilon naught I have taken here. Can I cancel Q and Q? Then let me write this A epsilon naught divided by D. So this is the a capacitance of a parallel plate capacitor. Are you okay with this? Okay, Q is equals, sorry, so capacitance of a capacitor C is equals to total charge by potential. The total charge this is, then potential I got from the parallel plate is a sigma D by epsilon naught. I know that where sigma is the surface area charge density. The surface charge density means a Q by A into D. So the Q by Q is got cancelled. Then let me write it as a A epsilon D. Okay, is it clear?
Can you show
Is
Ma'am.
it clear?
can you
Yes.
show
Can I go
previous?
to
Yes,
previous?
ma'am.
Yeah. Yes. Take it down.
Next page.
Yes.
Ma'am, 1 minute.
Yes. Can I go for previous page? Done, students? If you're done, you can join for the other class. Please take it down and leave. Tomorrow we can go for the, based on this, we can go for the numericals part. Please make sure with this capacitance and capacitance of a capacitor, parallel plate capacitor.
Thank you, ma'am.
Ma'am, capacitors and its
Thank
principle,
you.
ma'am.
Yeah, sure, dear.
Thank you, ma'am.
Yeah.